This lesson is going to discuss sets and compound inequalities, not only solving these, but also graphing these and writing them in interval notation. So when looking at inequalities, solving these for x, to be able to solve this first inequality, we would need to subtract 4 from both sides, and then we would have that x is less than negative 4. For the right-hand equation, because x is being multiplied by 6, we would need to divide both sides by 6 because we want one x on one side of the inequality and our constant on the other. So we would have x is greater than negative 12 divided by 6 is going to be negative 2. When marking these on the number line, make sure your smallest number is on the left, which in this case is going to be the negative 4. Would be to the left of negative 2 because negative 2 is closer to 0. And at negative 4 it says that x is less than negative 4. So because it's less than, we would use a parenthesis. If it were equal to, we would also use a bracket. But in this case we would use a parenthesis. Everything to the left of negative 4 is less than, so we would open our parenthesis to the left. For negative 2, because it says the inequality reads x is greater than negative 2, everything to the right of negative 2 is going to be larger. So in this case we would open our parenthesis to the right, and a parenthesis because we do not have an equal sign. And we shade in the direction that our parentheses or our brackets, whichever may be the case, is open. So this would be our solution graphically. As far as interval notation is concerned, because there is a break in the graph, this would be called a union. So we would put a U. We still write our interval notations from left to right. So as far as the shading is concerned, it shades all the way to the left, which is negative infinity to negative 4. Now, from negative infinity's point of view, it cannot equal infinity, so we would use a parenthesis because it cannot equal. Negative 4 already has a parenthesis illustrated in the graph, so it would also have a parenthesis. Writing this portion after the break in the graph, still from left to right, we would start with negative 2 because that's where it starts shading, all the way to the right, which is positive infinity. And these would both have parentheses, the parentheses coming from the graph as well as infinity. So all three of these could be your solution as far as the statement, x is less than negative 4 or x is greater than negative 2, the graph, and the interval notation. A second example for this means, because of the parentheses, we would actually distribute. So we would say 5 times x is 5x, 5 times negative 1 is negative 5, and once we distribute that 5, we're finished with those parentheses. We do not need them any longer. It's greater than or equal to negative 5. To be able to solve this for x, we would need to add our constant to both sides. Bring down the 5x because nothing's happened to it, is greater than or equal to, the 5's cancel out, so when everything cancels out on one side, you're left with 0. Now, to be able to solve this for x, we need to divide both sides by 5, and we have x, because the 5 divided by 5 is 1, is greater than or equal to 0 divided by 5 is 0, which is a legitimate number. The second inequality, still needing to solve for x, subtract 5 from both sides, bring down the negative x, the negative sign comes with that variable, less than or equal to 11 plus a negative 5 is going to give you positive 6. Now, to solve for x, we need to divide both sides by negative 1. Once we divide an inequality by negative 1, it takes the opposite meaning, which means we need to change the direction of the symbol. So instead of less than or equal to, it's going to become greater than or equal to. The negatives divide out to be a positive x. 6 divided by negative 1 is negative 6. So anytime we divide by a negative number, we have to change the direction of the inequality sign. Now we're going to graph these, and again, whichever number is smaller needs to appear on the left-hand side of the number line. And in this case, it would be negative 6. Would be to the left of 0. It does not matter how far these are spread apart, and your number line may be more detailed than this is. At -6, we have an equal sign. X is greater than or equal to -6. So that means we need a bracket opening to the right, because everything to the right is going to be shaded in. At 0, we have X is greater than or equal to 0. So in this case right here, both shadings would occur to the right of these numbers, but where they actually overlap would be just this portion right here. But when we write this statement or use the statement or, it's where everything is shaded. So as far as shading is concerned, if we were going to write our interval notation, we would write it as -6 because that's the furthest number shaded to the left, comma, shading occurs all the way through positive infinity, and again we would have a parenthesis right at the end of the infinity. We do not have a break in the graph, so we do not have a union.